Hi once again. We have earlier on seen question 4, part A of past exam paper, August 2014. Now we look at question 4, part B. Now question 4, part B provides a circuit figure 4.2, and we are tasked to calculate the total impedance and the current IS flowing into the circuit. Right, so we are required to calculate two things. One is the total impedance of this circuit, and then the other one is the total, the total incoming current. Right, let's see how we do this. Well, to answer this question, what I do is I would draw this circuit out very quickly. We have one impedance in series with two parallel impedance. So the first thing to do is to calculate what is the effective impedance of these two branches, and then add these two together. Right? So that's what I'm going to do. The total impedance here, looking into this whole circuit, is given as total impedance T is equals to impedance 1, let's call this impedance 1, and the parallel value of these two impedance. Right? So impedance 1 plus the impedance value of the parallel of these two. Right, so let's do the calculation for this one first. So the impedance for 2 in parallel with impedance of 3 is equals to the inverse value of 1 upon Z2 plus 1 upon Z3. Now this is since they are in polar form, we just use it as we need that. So it's 40 at an angle of minus 90 degrees plus 1 upon 20 at an angle of 0 degrees. The inverse of this. Right? So this gives us 0.05 0.05 is this one, I'm sorry. So this one is J 0.025 25 at an angle of 90 degrees plus 20 0.05 at an angle of 0 degrees, putting inverse. Okay. Convert this to rectangular form, I get 0.05 plus J 0.025. This is this, the inverse. Bring it back to polar form. I will have 0.0559 angle of 26.565 degrees inverse. Right? Inverse means 1 upon this, right? So this gives me let's do some quick calculation. Divided by 0.0559, 16.95. 16.95 at an angle of minus 26.565 ohms. Right now, then I can put this in. So what I get now here is 2 at an angle of minus 90 degrees plus 16.95 an angle of minus 26.565 degrees. Now we need to add them, so it's good to convert it back to rectangular format. Now 2 minus 90 is just j, minus j2. Convert this into rectangular format. I should get about 16 minus j8. That gives me 16 minus j10. Convert this back to polar form, should be angle minus 32 degrees. Okay, so that is the total impedance for this circuit. Then the next step will be very straightforward. The total current IS, according to Ohm's law, is just ES over impedance T. So it's 110 angle of 0 degrees divided by 18.87 angle of minus 32 degrees. That gives me 5.83 the angle of 32 degrees ampere. Alright, so that's the answer for total impedance and the current flowing in the circuit. Okay, so this is part B, August 2014 exam paper, question 4, part B.